Good morning, it's November 21st and this is your daily brief in science. Here's everything you need to know. A moss on a mission? A study in iScience shows Physcomitrium patens spores survived 9 months on the exterior of the International Space Station, with over 80% still alive and germination reaching up to 97% for spores shielded from UV light. The results suggest mosses could seed early, off-world ecosystems and support future extraterrestrial agriculture on the Moon or Mars. Interestingly, the spores germinated after their return to Earth, indicating potential revival post-mission, though the study does not claim evidence of extraterrestrial life. Experts caution the findings don't address cosmic ionizing radiation beyond International Space Station shielding, a major hurdle for deeper space missions. Dr. Tomomichi Fujita notes the work covers survival and early revival, while calling for more research on growth and viability in varied space environments. The research explicitly aims to explore viability and revival, not to assert life beyond Earth, aligning with the idea that life's building blocks could be widespread. Related experiments on the International Space Station with Antarctic mosses exposed to radiation and low gravity are ongoing, with results pending. While the spore resilience is encouraging, International Space Station conditions do not replicate deep space environments, so growing plants in true space conditions remains a broader challenge. Dr. Agata Zupanska points out external International Space Station conditions differ from deep space, emphasizing the practical goal of extraterrestrial plant growth rather than mere survival. Astrobiologist Daniela Billy notes the dormant, dehydrated state and protective sporangium likely aided survival, whereas hydrated, active samples would face greater radiation and environmental stress. SETI Institute scientist Agata Zupanska highlights radiation as a core concern for seed viability in deep space and notes moss is highly radiation-resistant on Earth. Physcomitrium patens is a model organism in plant biology due to its sequenced genome and relevance to studying plant evolution and stress tolerance. A new mechanism of synaptic plasticity has emerged with extracellular phosphorylation by secreted kinases in the synaptic cleft guiding EphB2 NMDA receptor interactions and injury-related pain. In mouse studies, removing the extracellular kinase VLK from pain-sensing neurons reduced postoperative pain without impairing normal motor or sensory function, while increasing VLK-amplified pain responses. The findings point to therapies that locally inhibit VLK to relieve pain, potentially avoiding side effects tied to direct NMDA receptor modulation. Co-first authors Koluru Srikanth, Praveen Chander, and Hallie Washburn originate from the Dalva lab at Tulane, with Ted Price and Matthew Dalva leading the work published in Science. The study shows that presynaptic deletion of PKDCC disrupts EphB2 phosphorylation and blocks EphB2 NMDA receptor interaction in dorsal horn neurons after injury, without altering baseline protein expression. Researchers note that extracellular phosphorylation has been observed before, but its role in the nervous system was largely unclear until now. The work hints at a broader mechanism where extracellular phosphorylation can influence cell interactions, potentially simplifying drug development and reducing off-target effects by avoiding cell entry. Next steps aim to determine whether this mechanism applies to other proteins and biological processes, with potential broad relevance for neurological and other diseases. The Science Report, published November 20, 2025, details that the synaptic ectokinase VLK triggers the EphB2 and MDAR interaction to drive injury-induced pain, with a consortium spanning UT Dallas, UT Health San Antonio, UTMD Anderson, University of Houston, Princeton, UW-Madison, NYU, and Thomas Jefferson University. Key authors include Hajira Elahi, Ted Price, and Matthew Dalva, with UT Dallas CAPS a major contributor, supported by NIH funding from NINDS, NIDA, and NCRR. A new oral GLP-1 receptor agonist called orforglipron from Eli Lilly is showing promise as a weight loss option that could be cheaper and needle-free. In a Lancet Phase 3 trial, more than 1,500 adults with obesity and type 2 diabetes across 10 countries who took orforglipron plus diet and exercise achieved about 10% body weight loss, with the highest 36 mg dose over 72 weeks, versus roughly 2% with placebo. Weight loss with the oral drug is similar to non-diabetic obese populations in prior studies, around 12%, but still lower than the roughly 22% seen with weekly injectable Mounjaro over the same period. Experts say the pill could improve access and reduce logistical hurdles since injections and cold chain storage would not be required. Injectable GLP-1 treatments can cost over $1,000 per month in the United States, fueling calls for cheaper generics to boost access in lower-income countries. The trial found the drug was generally well tolerated, with gastrointestinal side effects such as nausea, vomiting, constipation, and diarrhea described as mild to moderate. FDA approval is being sought for treating obesity and type 2 diabetes, potentially as early as next year, with hopes that all 3 doses are approved to optimize care. If approved, orforglipron could be available in 2026 at a significantly lower cost than injectable GLP-1 therapies, potentially improving affordability and insurance coverage. The Lancet study, funded by Eli Lilly, suggests the oral option could offer a more convenient and cheaper alternative to injections if approved. Analysts expect strong competition in the obesity treatment market, with late-stage results and ongoing development of oral formulations influencing stock movements. In the UK, more than 2.5 million people use weight loss injections, while obesity imposes substantial health and economic costs, estimated at around £74 to £100 billion annually. GLP-1 drugs, originally developed for diabetes, are being explored for broader benefits beyond weight loss, including heart disease and sleep apnea. Coastal nurseries have long fueled shark and ray diversification, but today those shallow, species-rich habitats face growing threats from development, warming, pollution, and overfishing. New fossil research suggests these nearshore environments shaped the evolution of neoselachians, underscoring why conserving reefs, seagrass meadows, and other nearshore systems matters now. The study, published in Scientific Reports on November 20, 2025, is led by Manuel A. Stagel of the University of Vienna, with contributions from Jürgen Krivet and the Institute of Paleontology. Analyzing 49,750 fossil occurrences across 503 genera, researchers reconstruct Cenozoic diversity and find a mild post-Cretaceous dip, a strong Eocene radiation, and a long-term decline without full recovery. The work reframes evolutionary history and offers data-driven guidance for modern conservation strategies. The authors argue for preserving and restoring diverse coastal habitats and aggressively reducing CO2 emissions to curb ocean acidification, stressing a holistic approach beyond fishing quotas. A new fossil analysis shows sharks and rays have experienced a 100 million-year decline in genus diversity since a warm Eocene peak about 45 million years ago, challenging the idea of stable modern diversity. Deep-sea sharks followed a distinct trajectory, expanding during surface water cooling as lineages moved to deeper or higher latitude waters, reflecting long-term ocean geography and climate shifts. The fossil record shows that shallow coastal habitats have been crucial nurseries and feeding grounds driving neoselachian evolution, and today they face intensified human pressures. Atmospheric CO2 had a nuanced effect. Moderate levels supported productivity and diversity through habitat growth, but excessive CO2 drives ocean acidification and harms modern biodiversity. Paradromics has cleared a major regulatory hurdle to begin early human testing of its Connexus brain-computer interface, aiming to help severely motor-impaired patients communicate through text and synthesized speech. The FDA granted an investigational device exemption, approving the Connect 1 early feasibility study and marking the first IDE for speech restoration with a fully implantable BCY. A long-term trial is also approved to evaluate safety and function, with plans to implant devices in 2 volunteers who cannot speak due to neurological diseases. Paradromics positions itself as a competitor to Neuralink and Synchron, pursuing high-bandwidth, densely implanted BCIS with distinct approaches. Early goals include detecting imagined hand movements to enable cursor control, with potential expansion to 10 volunteers and a second cortical implant to enrich signals. 2 clinical sites are within 4 hours travel for participants, reflecting a multi-site approach to validate safety before broader testing. The broader BC1 market is seen as expansive, with investment interest and Morgan Stanley projecting multi-hundred-billion-dollar potential. Preclinical data in sheep showed about 200 bits per second data transfer, though direct comparisons to rivals are limited by differing task paradigms. Experts emphasize the promise of fully implantable systems and call for transparency and independent academic access to devices. Paradromics expects users to speak at roughly 60 words per minute via the BC1, with potential voice cloning from a recording of the user's voice when available. The system records cortical activity, maps intended speech, and outputs results to a screen for approval or to generate voice from stored recordings. The Connexus device is a small disc-like implant with 421 microwire electrodes, contrasting with rivals using larger skull-embedded chips with thousands of electrodes. The study is set to begin next year, led by CEO Matt Engel, and aims to demonstrate high-bandwidth neural communication to restore speech and computer control. The initial study will enroll 2 participants next year to assess long-term safety and the device's ability to enable communication, with data collection planned for about a year before expanding to more volunteers. This has been your daily brief in science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. We'll be back Monday with everything you need to know.